Alright, so we'll start with the geometry network. I'll call it sim, change the color here like always, and we'll dive inside. So what we are going to need is, we need to first create our pieces. So for that, let's create a box. This is a pretty basic square box or cube, and I'll just change the size here a bit. Let's change the X size to 13.5, and in the Z direction I'll change it to 6.25 or 24, something like this, so that we get something rectangular. Also, maybe I can decrease the size here like this to 0.85, and okay, so this is looking nice. Let me just move it a bit up in the Y direction like this. So because we'll be having our ground plane there for collision, and this is looking nice. Okay, so what I want is, I'm going to generate pieces inside this box by scattering some points. Okay, so let's just scatter some points here, and for that what I'm going to do is I'll use a ISO offset so that we have a volume here. I'll just change the uniform sampling divisions to 100 so that it has a proper shape. Now let's scatter some points, maybe 1,000 points. Yeah, 1,000 points are going to be good. Now we have 1,000 points here, and we need to copy our geometry on these points. Okay, so let's create a basic sphere. This is just an example that I'm showing right now. So let's change the primitive type to polygon, change the frequency to 10, and now we are going to use a copy to points to copy that sphere onto our points. Okay, and this is what we are getting. Our sphere is being copied onto our scattered points, which is pretty nice. So let's change the uniform scale a bit here, 0.25. This is looking nice now. Alright, so what we can do is, for the RBD collision, we are going to need a packed object. Okay, an object that is going to take participation in the RBD simulation needs to be packed. Okay, and for that we are going to use a pack node here before our copy to points. So all these points which are being scattered, all these spheres which are being scattered on the points, which are being copied to the points, are packed. So let's use a RBD configure node here. With the help of the RBD configure node, we can give some extra attributes to our geometry, such as mass and bounce, etc., for our RBD simulation, and that is why I'm using RBD configure also pack your geometry, by the way. So everything looks fine to me. We can just move our box a bit and come to the RBD bullet solver, come to collisions here. Where is collision? Yeah, here, collisions, and we'll turn on our ground plane. So now when we look at it, okay, the points are colliding, the spheres are colliding. I'll move it up a bit like this. Just make sure that the spheres and the ground are not colliding on the first frame. Let's run this and see what we are getting. So the balls are falling down, the spheres are falling down, and that's what we wanted. This is the video. It is over. Thank you very much. Actually, no, I was just kidding. This is working fine. The spheres are working fine. So this was our basic test for our RBD simulation. Now we can replace our spheres or our balls here with something more interesting. Okay, it is working fine, like a fine wine. Okay, so everything is looking nice. What we can do now, as I said earlier, we can replace this sphere with something interesting. And as you can see in the preview, what I've used is a Instagram like. So that's why I'm using a file. I'll just import the object here, which I have modeled myself. It will be provided with the project files. This is Insta like square. It is a Alembic file. So let's just select that. Okay, so we have our we have our file here. Let me just turn it on, put the template on this. Okay, so this is looking nice. I'll just unpack this. Because this is an Alembic, I'll use a convert node just to make sure that everything we are getting is a polygon. Okay, and after this I'm going to use a reverse convert. Yeah, that was connectivity. Yeah, so after the convert node we are going to use a reverse, and a reverse to get the normals proper, and we can replace our sphere with this in our copy to points node. Okay, so now let's see what we are getting. Let me just put the flag here, and you can see our Instagram like geometry is being copied to all of our points. What we can do here is we can actually move it up a bit, and we can play with the transformation. So let's use a transform node, and in the transform node I'll just move it up, and in the Z direction probably. So let's just move it up first. Okay, and okay, a bit, like something like this. I can also play with the values, 0.65. Okay, this is looking nice. Let me visualize this. Okay, so what we can do now is, instead of playing with the scale value here, we can control the p scale value. But before that, I'll just use a material node for our insta like, because we'll be using our material here, which we will create later. And after that, I'm going to pack this. Pack node is necessary. As I said, the geometry that is being used for our RBD simulation needs to be packed. Okay, so that is that. And as I said, we can control our p scale values for each individual point here, and for that I'm using a scatter and align node, and just change it to scatter points. Actually, what is this? Okay, actually change it to add attributes to existing point cloud, and here we can change the minimum radius to 0.2. Let's change the maximum radius, something like 0.35, and you can see the p scale values are running from 0.2 to 0.35. We can also bring down the uniform scale a bit, something like this, and this is very uniform. We can change the normal direction to Z, but that is not going to affect because we have not put the like geometry in the Z direction. So come to the rotation and play with the rotation values here, like this, maximum offset angle, something like this. And as you can see, every point has a different rotation value, which is being inherited by our like geometry, and that is why everything is being rotated randomly. We can move it up a bit, something like this. Okay, let's run this RBD bullet sim, and let's see what we are getting. And as I run the simulation, everything is falling down properly on our ground plane, and that's what we wanted. Okay, so this is looking nice. What more we can do? What more interesting we can do? So for that, let's just go back to, let me just see if there's any problem here. Okay, so now everything is looking fine. This sim is running proper. Maybe I can give it a bit of color here, and let me just run the colors here. 383, 38E3, FF. This is the color that I liked. This is the color that I actually used in my preview, so that's why I'm using it here. So after coloring all these like buttons, what we can do is we can have a big Instagram logo that is going to fall on all these likes. Okay, as you saw in the preview. So to do something like that, let me just first align this properly, and what we can do is we can bring that Instagram logo that I created. So let's just align this And let me align this now. Everything should look nice, guys. That is the main priority. Even if you don't learn anything, even if you don't know how to use Houdini, you should just keep everything clean. So I have used a file node here, and I have brought my Instagram logo here. Okay. By the way, I was just joking earlier. So this is what we are getting. A convert node I'll be using to convert this to polygon, just to make sure that everything here is a polygon. And the thing here is that these are 4 individual geometries. So I'll use a transform node. Maybe I'll make it a bit, and I'll show you what I meant earlier. Maybe I'll bring it a bit, 0.42 in the y direction, or maybe 1.42, 0.2, something like this. Yeah, a bit above the ground. That's what we need. So after the transform node, as I said, these are 4 individual geometries. Okay, and we need to make this one geometry. And first we can do is apply material, and then we will use the pack node here, PACK. And when I use the pack node, you can see this has now become one individual geometry. Everything is packed into one point. If I use a RBD configure, and if I just connect it here, and if I show you here, you can see that there are 6 points here, which means there are 6 geometries, 6 packed geometries there. But we are using a packed geometry node here, to pack our geometry into one piece, one point. Okay. And after this, we can use a RBD configure node. And as I said earlier, RBD configure node is used to provide some extra attributes that we can provide to a geometry, like bounce and mass and density. Okay, so let's go to our physical attributes, turn on the density here, and this is that our density is 1000. And if you come here, this is a smaller size. So these all like buttons are smaller scale, so their density is going to be smaller. This our Instagram logo is a bit bigger, so the density here should be a lot bigger. What I mean is, when we apply forces, I do not want all of them to move similarly. Okay, turn on the bounce here, and we do not want it to be a lot bouncy, so 0.1 is proper. I'll use a color here, and maybe I'll use something like pink here. Okay, a little pink in our life is always good. Okay, so what are we going to do now? Okay, what we can do now is, let me just bring it here, so all of them are at the same eye level. I'll use a RBD pack node. I'll just pack our earlier like geometries, and I'll use the RBD pack node here. So copy it. I'll connect it to first, connect the constraints to the second one, third one is proxy geometry. Okay, so this is pretty similar to our vellum geometries. Whenever we are merging 2 different vellum geometries or vellum constraints, we are using vellum pack, and similarly here we are using RBD pack. Let's use a RBD pack node now, and we will be getting our geometries, our constraints, and our proxy geometries. So this is what we're getting. And from the first view, I can see that I can move the logo a bit up, and okay, this is looking nice. Let's run this and see what we are getting. And bam, RBD simulation is pretty quick, man, and I love it. I have tried the similar things with the help of vellum grains in vellum simulation, but whenever I am doing that, the simulations are pretty slow. So that's why I love the RBD simulations. They are pretty quick for simple things. So this is what we are getting. Our logos and our likes are falling down, and in my original simulation, which you actually saw earlier in this video, I have used some forces which I think we'll be using now. Otherwise, you would be saying that we already know. We already knew how to do this. How did you do that exact thing? Teach us that. And that's what I'll be doing. Okay, so I think I have run this enough number of times. So maybe we can do it one more time. You know, life is too short to not run our simulation one more time. Actually, life is big enough to run our simulation one more time. I said the wrong thing earlier. Okay, so now that we have our RBD simulation, this is a pretty basic example, guys. Okay, the main things that you need to consider when you are running a RBD sim is that the geometry needs to be packed, and if you have something to collide, that is awesome. So this is a pretty basic simulation. I think you will learn the basics now. You can run a pretty basic simulation even if you change the likes and the logo of the Instagram here with something else. It is going to run the similar, and instead of running a lot of points here, a lot of geometries, you can just do the same exact thing with just one geometry. That's what I have shown here. The likes here are a lot more, a lot of geometry there, like geometry, and even if you don't want to do it, you just want to run the RBD simulation with one geometry, and I have shown that to you with the example of that Instagram logo. Okay, so moving on now, what we can do is, let me align this as I said earlier. Even if nothing is working, you should have a clean project file. So after this, what we are going to do is we are going to create a box here, which is going to be behaving like a collider for our simulation. Okay, so come to the transformation, and I'll turn this flag. I'll move it up a bit, maybe bring it down, something like this, and instead of moving it, I'll just increase the size in the Y. Let me just keep it here. Now let's increase the size in the Y direction. Increase the size around 2.3, or maybe something even bigger. I think we can increase the size in the X and Z direction as well. So something, you have to increase it, sorry, not decrease it. What am I doing? Let's decrease it, maybe. Okay, let's just move it here. Uniform scale needs to be increased. Okay, 1.5, maybe 1.6. Yeah, this is looking nice. We can move it down now, something like this, and this box is going to behave as our collider. Okay, so let's move it down a bit, and this is a closed box. We need to open it. So what I'm going to do is I'll just select the top part of it, this primitive, and I'll just press delete button, and this will give me a blast node which has already deleted that part. I'll use a reverse node so that the inside part, reverse node to reverse the normals. That's what I meant. Okay, I'll just connect this geometry to our collider input like this, and now you can see these are our like buttons, and that is our Instagram logo. And when we run the simulation, let's see what happens. Okay, so they're actually completely ignoring our box. And why is that? They're falling through it, and the Instagram logo isn't even moving. So There must be some problem here, and I think I know what it is. So if I see it here, okay, yeah, that's the problem. Come to our collisions, change the collision shape to concave. That's what we need. Okay, and now if I change it to deforming, do we need it? No. Now when we run this, you can see that everything should be fine, I think. Yay. And that's what we wanted. Our Instagram likes and Instagram logo, all the geometries are falling down properly in our box. And now we can work on the forces here.